the water softening methods. Okay, ma, all of you audible my voice, ma?
Yes, sir.
Okay. So first of all, water softening methods. So what is the definition for the water softening? I think all of you know about the what is the soft water and what is the hard water. So soft water means the sample of the water which is free from the dissolved salts. That means the sample of the water which is readily to give the lather with soap. That is called the soft water. Whereas hard water means the sample of the water which does not give the lather with soap or rubbing with soap because of the so many salts present in the water. Because of that salts, the sample of the water does not give the lather with soap. Okay, amma? So that is the about the definitions of soft water and hard water. Now our method is the softening of the water. So softening of the water means the process involves to remove the hardness caused salts. Hardness caused salts from the sample of the water. Okay, water softening methods. Water softening method means it is the process involves the removal of the hardness caused salts from the sample of the water. So that is called the water softening. So this water softening mainly involves the two types. One is internal treatment methods. Second one is the external treatment methods. Okay, internal treatment method means water softening takes place within the boilers. Whenever they use that water for the purpose of boilers and to remove that hardness caused salts within the boiler, that is called the internal treatment methods. Another method is external treatment methods. That means the water softening process involves before entering into the boilers. That is called external treatment methods. So that is the difference between the internal treatment and external treatment. So internal treatment means conditioning of the water in the boiler itself by adding of the chemicals. So that is called the internal treatment methods. Whereas external treatment method means treatment is done before entry of the water into the boiler. Before entry of the water into the boiler. So that is called the external treatment methods. Okay, so that is about the water softening methods. So what is the water softening? Water softening. The process of removal of hardness caused salts from the sample of the water. So that is called the water softening. Okay, amma, how many methods present in the water softening, amma?
Internal and external.
Okay, very good. Internal treatment and external treatment methods. So internal treatment methods means water softening takes place within the boilers. Within the boilers. That means conditioning of the water in the boiler itself by adding the chemicals. That is called internal treatment methods. So external treatment methods means the process of removal of hardness causes salt. That is nothing but a softening of the water takes place before entering into the boilers. Before entering into the boilers. So that is called the external treatment methods. Means treatment is done before entry of the water into the boiler. Okay, ma? But as per our syllabus, we have only external treatment methods. We have only external treatment methods. Okay, ma? So let us start the external treatment methods. So as per our syllabus, ion exchange method is the best example for a external treatment method. Okay, ma. So what is the example for the external treatment method, ma? Ion exchange process. Ion exchange process, deionization or demineralization of the water. So why the process is called as ion exchange process? Because this process involves the exchanging of the ions. That means either cations or anions. Exchange of the ions mainly involves that may be either cations or anions. That's why this process is called as ion exchange process. So because of that process, what happens? It removes all the ionizable ions present in the water. So that's why this process is also called as deionization or demineralization. Demineralization means the sample of the water which should be free from all the dissolved salts. The sample of the water which should be free from all the dissolved salts. So that is called demineralization. So this process mainly involves the the process of removal of all the dissolved salts present in the water. So that's why this process is called as either deionization or demineralization of the water. Or based on the process, this process is also called as ion exchange process. Okay, ma? Now we see the definition. Ion exchange process is defined as the reversible exchange of the ions in the structure of an ion exchanger to ions in solution that is brought into contact with it, and the resin used for the purpose is called the ion exchange resins. They are porous, insoluble, cross-linked, long-chain organic polymers capable of exchange of the ions. Okay, so first of all, the ion exchange resin have ability reversible exchange of the ions. Reversible exchange of the ions. That may be either cations or anions. It may be reversible exchange, and because of the that possible only the structure of the ion exchange. So that ion exchange is present in a solution of the sample of the water, and it can exchange the both cations and anions. So for the cations we use the cation exchange resin. For the anions we use the anion exchange resin. So that's why this resin is mainly classified into two types. One is cation exchange resin, and the second one is the anion exchange resin. One is cation exchange resin, and second one is the anion exchange resin. Okay, amma. So first of all, and the nature of this resin, the nature of this resin is mainly porous nature, insoluble, cross-linked, and long chain organic polymers. Long chain organic polymers, and main important property is capable of exchanging ions. Okay, ma. So this is about the nature of the resin. Okay, ma. Now tell me how many types of exchanging resins, amma?
Two types.
Two types, amma. First one is
cation and anion.
cation exchange resin, and second one is the anion exchange resin. So what is the nature of resin, amma? What is the nature of resin? It is porous. First one is porous, and second one is insoluble. Third one is the cross-linked, and fourth one is the long chain organic polymers capable of exchanging ions. Okay, ma. Generally, long chain means polymers, and long chain organic polymers capable of exchanging ions. Okay, ma. So this is about the basic introduction to the ion exchange process and types of the ion exchange. So now we see the first resin is nothing but a cation exchange resin. Cation exchange resin. So first of all, what is cation exchange resin? This resin is applicable to exchange of the cationic hardness caused salts from the sample of the water. Cationic hardness caused salts from the sample of the water. Already we discussed about in previous classes, that is types of hardness. How many types of hardness, amma? How many types of hardness, amma? At least say a number. How many types?
Temporary and permanent.
Two types, amma. Okay, amma. Very good. What are they, amma?
Temporary and permanent.
Temporary hardness and permanent hardness. So temporary hardness is caused by which salts? Temporary hardness.
Carbonates,
Carbonates, bicarbonates,
bicarbonates,
hydroxides, salts of the calcium and magnesium. Okay, amma. Whereas permanent hardness, amma?
sulfates, or
Nitrates,
chlorides,
nitrates, sulfates.
Nitrates of the
Sulfur.
calcium and magnesium. So finally, you understood that the hardness of the water is caused by the salts of calcium and magnesium, and that hardness is caused by both anionic ions and cationic ions. So we differentiate the hardness, cationic hardness and anionic hardness. So we observe either temporary or permanent hardness. The cationic hardness is common. Why? Because the hardness is simply caused by the salts of calcium and magnesium. If it is temporary hardness or permanent hardness, the cationic hardness is common. Always, what are the cations caused the hardness? Calcium and magnesium. But what are the anions caused the hardness? They may be depends upon the type of the hardness. If it is temporary hardness, bicarbonates, carbonates, hydroxides causes the temporary hardness, whereas chlorides, sulfates, nitrates causes the permanent hardness. So finally understood that it is need to remove that hardness caused salts. That means either cations and anions both are separated from the sample of the water. So that's why this is the best process. Why? Because it involves the both cation exchange and anion exchange. Okay, ma? Now we see cation exchange region. So this cation exchange region applicable to remove the cationic hardness, from the sample of the water. Okay, ma? So first of all, these are the materials capable of exchanging cation in their structure to the cation in the solution. That means it removes the cationic hardness. Okay, ma, tell me what are the ions example for cationic hardness, ma? Ma, what are the ions causes the cationic hardness?
Ca+2 and Mg+2, sir.
Okay, ma, very good. Okay, ma. So for softening of the water, the resins used should be capable of exchanging H+ ions in their structure to other cations in the solution. Okay, ma, already previously I said that it is the resin ability to exchange the cations. So that cations are exchanged by the H+ ions. So this H+ ions is linked with the resin. Okay, ma. So commonly used resins are styrene divinyl benzene copolymers. Already in the previous slide, I said that the nature of the resin is the porous, insoluble, cross-linked and long chain organic polymers. Okay, ma. So now we see what is the example for the cation exchange resin, ma? Styrene divinyl benzene copolymers. Okay, ma. So which on sulfonation or carboxylation. So that styrene divinyl benzene undergoes a reaction either sulfonation or carboxylation. Sulfonation means reacts with the sulfonic acid groups. That means SO3H. Whereas carboxylation means reacts with the COOH. Carboxylation means COOH groups become capable of exchanging hydrogen ion with the cations in the water. Okay, ma. So the general representation of these cationic exchange regions are RH. In this R having the negative sign and H having the positive sign. Why? Because these H+ ions having the ability to exchange the cations from the sample of the water. So where R is called insoluble polymer matrix and H+ is the exchangeable ion. H+ ion is the exchangeable ion. And what are the commercial examples for the cation exchange regions? Amberlite IR120 and Dovex 50. These are the commercially examples for a cation exchange region. That means Amberlite IR120 and Dovex 50 are the examples of commercially available cation exchange regions. So in the previous slide, cation exchange region is possible by either by sulfonic acid groups or carboxylic acid groups. Sulfonic acid means SO3H or carboxylic acid means COOH. So we observe that either in SO3H or COOH, what happens? H+ is present. So that H+ having ability to exchange the cationic hardness from the sample of the water. Okay, ma? So this is about the cation exchange region. Okay, ma. So what is the general representation for cation exchange region, ma? RH, where R means
Insoluble polymer matrix.
okay. What is the H+ role?
Exchangeable
ion. Okay, ma. So what are the ions exchanged by the H+ ion, ma? What are the ions exchangeable by the H+ ions?
Ca+2 and Mg+2, sir.
Okay, ma. Cations. Very good. So what are the commercially examples for cation exchange region, ma?
Amberlite.
Amberlite IR120. And second one is Dovex 50. Dovex 50. Okay, ma. Next we see anion exchange regions. So anion exchange regions. Already we exchange the cations. Now the next process is the anion exchange region. So this anion exchange region is the different for both the temporary and permanent hardness. Why? Because the temporary hardness is caused by the bicarbonates, carbonates also of calcium and magnesium. Whereas permanent hardness is caused by the chlorides, sulfates and nitrates of the calcium and magnesium. Okay, so these are the materials capable of exchanging anions, in the structure to anion in the solution. So what is the exchangeable ion? OH. Okay, so anion exchangers employed for the water softening are styrene dimethyl benzene or amine formaldehyde copolymers. Previously in cation exchange we use only styrene dimethyl benzene, but in the anion exchange region we use the either styrene dimethyl benzene or amine formaldehyde copolymers. So which contain mainly basic functional group such as amino or quaternary ammonium or quaternary phosphonium or tertiary sulfonium groups as an integral part of the resin matrix. So that means generally the basic structure is the either styrene dimethyl benzene or amine formaldehyde copolymers, and which contain the functional groups that may be either amino or quaternary ammonium or quaternary phosphonium or tertiary sulfonium groups. So these are the groups exchanging the ions from the sample of the water. And what is the general representation of ROH? In this case, where R represents the insoluble polymer matrix and it gets the sign positive sign, and OH minus. Why? Because it is the anion exchange. That's why OH minus is the exchangeable ion. And what are the commercially examples for the anion exchange regions? First one is the amberlite 400 and second one is the Dovex 3. First one is the amberlite 400 and second one is the Dovex 3 are the examples for a commercially available anion exchange regions. Okay, ma? So this is about the anion exchange regions. Okay, ma? So tell me, what is the representation for the anion exchange region, ma?
ROH.
ROH, where R is equal to
insoluble polymer matrix.
so insoluble polymer matrix. That is nothing but a resin. Okay, ma. And what is the role of OH, ma?
Exchangeable ion.
Exchangeable ion. Okay, ma. So what is the representation for cation exchange region, ma?
RH.
In RH, what is the exchangeable ion, ma?
H is the
H plus.
H plus is the exchangeable ion. In ROH, OH minus is the exchangeable ion. Okay, ma. And what are the commercially examples for anion exchange regions, ma?
Amberlite
400 Dovex 3.
Amberlite 400 and Dovex 3. Okay, ma. Okay, ma. Now all of you understood about cation exchange region and anion exchange region, ma?
Yes, sir.
Okay. So now we see the structure of the anion exchange region. So this anion exchange region having the amino groups and linked with the either quaternary or tertiary ammonium salts or phosphonium salts. Okay, ma? So just I show the structures of cation exchange region and anion exchange region. But in case of the examination point of view, there is no need of to draw these two structures. Just you know what is the functional groups present on the cation exchange region and anion exchange region. For cation exchange region, sulfonic acid groups are present. That means SO3H or carboxylic acid groups COOH. Whereas for anion exchange regions, present amino acid groups. That means amino groups NH2 substituted with either quaternary ammonium salt or tertiary ammonium salts. Okay, ma? Now we see what is the process takes place both cation exchange region and anion exchange region by taking a water sample. That means that water sample containing a hardness of the water. Okay, ma. So first of all, we see by taking an example of the hard water from the sources of the water. that may be either surface water or groundwater, especially groundwater containing so many salts. Okay, so first of all, the hard water is first passed through the column of cation exchange region. That means the process involves initially to remove the cations from the sample of the water. Hardness caused cations from the sample of the water. After that, anions hardness caused salts from the sample of the water. Okay, ma? So first we pass that sample of the hard water into the cation exchange region. That means all the cations are removed and equivalent amount of the H plus ions are released from this column to the water. After that, what happens? The water coming out from the chamber at low pH, because of the exchange of the H plus ions. That means the H plus ions present in the water and exchange of the that cationic hardness. So because of the presence of the H plus ions, what happens? Water having the low pH, and now we see what is the process. I think all of you know what are the salts causes the cationic hardness, both calcium and magnesium ions. And you know what is the representation for a cation exchange region, RH. So by taking the example of a calcium, for example, if water containing the hardness causes salts calcium and resin is the cation exchange region, so it is represented by RH. What happens? This resin acquires captures that hardness caused salts from the sample of the water. That means this resin captures the calcium ions and release the H plus ions. Already I said that in cation exchange region, what is the exchangeable ion? H plus ion. So initially that resin having the H plus ion and which involves the process. What happens? It captures the calcium ions and release the H plus ions. So for example, if you can take as the magnesium ions, what happens? That resin captures the magnesium ions and release the H plus ions. That means the resultant water containing the only H plus ions. Because of the presence of H plus ions, the water having the low pH value. So after that, what happens? It is passed through a anion exchange region. So that means then the water is passed through second column containing anion exchange region. So in anion exchange region, what happens? All the anions are removed and equivalent amount of the OH minus are released. So that means previously H plus ions are exchanged the calcium and magnesium ions and releasing of the H plus ions. Whereas in second case, anion exchange region, what happens? ROH is involved and it exchanges the anionic hardness caused salts from the sample of the water. So by taking the resin matrix, so what is the anion exchange resin matrix? ROH. And what are the salts causes the anionic hardness? That may be either chlorides, sulfates or carbonates. So these chlorides and sulfates causes the permanent hardness and carbonate ions causes the temporary hardness. So by taking the examples of either permanent hardness or temporary hardness, first of all, we consider the permanent hardness. So permanent hardness is caused by the chloride salts. So ROH plus Cl minus, what happens? This region captures the chloride ions. That means exchanging of the ions OH and Cl and releasing of the OH minus ions. So finally, from the cation exchange region, H plus ions are released. From the anion exchange region, OH minus ions are released. So that means the H plus ions are released from the cation exchange column and OH minus ions are released from the anion exchange column, combined to produce a water molecule. That means from the cation exchange region, H plus ion is released and from the anion exchange region, OH minus ion is released. Finally, these H plus and OH minus combined to give a water molecule. So that resultant water having the pH is exactly 7. Why? Because it will be neutralized water because of the combination of H plus and OH minus. So the water coming out from the exchanger is free from all the cations and anions. Initially, I said that what is the definition for the demineralization? The sample of the water should be free from all the dissolved salts. That means it should be free from all the dissolved cations and anions. So it is called ion free water and is called as deionized water or demineralized water. Okay, so this is the diagrammatic representation of a ion exchange process. Initially it is having the cation exchanger, and after that it is having a anion exchanger. Okay, so in the cation exchanger, what happens? It exchanging of the cationic hardness by the H plus ions, whereas in anion exchanger, what happens? It exchanges the anionic hardness, that may be either chlorides, sulfates, nitrates, by using the OH minus ions. Okay. Okay, ma. I think time is over, ma. So tomorrow we discuss about the regeneration process, ma. Okay, ma. Now all of you understood the process involved in ion exchange process, ma, by cation and anion exchangers.
Sir.
Okay, ma. All of you understood process.
Yes, sir.
Yes, sir.
Sir.
Okay, ma. So tomorrow we discuss about the regeneration. Okay, ma. Thank you.
Attendance, sir.
అటెండెన్స్ ఆటోమేటిక్ వస్తామా, జూమ్ లో మీరు అందరు లాగిన్ అయ్యారు కదా, ఓకేనా? ఇప్పుడు డొమైన్ మెయిల్ ఐడి లాగిన్ అయ్యారా మీరంతా జూమ్ లో?
Yes, sir.
Sir.
ఓకే అమ్మా, ఓకే అమ్మా, థ్యాంక్ యూ.
Thank you, sir.